all this. Looks very complicated, but always remember, for our simplification of algebraic fractions, the more complicated it is, the more likely there is a chance for us to factorize and then to cancel all the common factors. Don't be afraid of them. So the strategy, okay, look, there's an x squared, it's quadratic, power 2. Let's try to factorize it. Okay, let's start with the first one. So we have x squared and 12. Clearly this must be x and x. Now in order to get 12, we can choose to have 1 and 12, 2 and 6, 4 and 3. And then at the back of our minds, we have to consider, how are we going to achieve this positive 7x? I think the 4 and the 3 has a high chance. So if I choose 3 times 4, for example, 3 times x will be 3x, x times 4 will be 4x. They add up to be 7x. So here I have factorized. I have already factorized the first numerator. So that gives me x plus 3, x plus 4. The moment I can factorize, I know I'm on the right track already. I'm pretty sure my denominator can also be factorized, and then probably I can do some cancelling with the fraction on the right. Okay, so the next one, denominator of x squared minus 36. This 36, you have to recognize perfect squares to become 6 squared. So it becomes a case of a squared minus b squared. See, x squared minus 6 squared, and that gives us a plus b, a minus b. These are things that you have to memorize. No point trying to factorize out your a squared minus b squared from the start. Okay, no point. Just memorize that it is a plus b, a minus b. So in our denominator, it becomes x plus 6, x minus 6. Okay, and then I'm disappointed. Nothing that I can cancel with. Top and bottom, nothing to cancel. Disappointing. But wait, there's a divide by another fraction. So instead of division, we change it to a multiplication, and we flip the second fraction over. X plus 6 over x plus 4. And now I see common factors. There's a x plus 4 and x plus 4. Cancel away the entire x plus 4. Because in this denominator, it is actually x plus 4 multiplied by 1. Okay, that is why we say the entire x plus 4 is a factor. It is multiplied by 1. So when you do such a cancellation, we are left with a 1 in the denominator. Same as what you did in your primary school. When you have, for example, 3 over 8 times 2 over 3. Let's make this a 6 instead. So when you start to cancel this way, 6 and your 3, you're left with a 2, and you write 1 over here. It's the same thing. Because we have 3 times 1 equals to 3. Okay, so we have just cancelled away one set of common factor, and clearly we have another x plus 6 as well as x plus 6. And this simplifies to become x plus 3 over x minus 6. You see that this is a much simpler form than the original. Simpler, easier to work with, easy to do substitution if we need to. And then the last question. Wow, I see quadratic everywhere, I see power 2 everywhere. Gonna be lots of factors, I assume. Okay, so let's start with the first one. Y squared and 3. So this will be y and y. To obtain a 3, it will be 3 times 1. Okay? Then now, we try to fill in the blanks. 3 times y, we get 3y over here. Y times 1, I get y. Okay, now, 3y and y gives me 4y. But that is different from this negative 4y. I want it to be a negative 4y, but currently it is positive 4y. I want it to be negative. So how do I make that happen? If only I can put in a negative sign over here. If only I can put in a negative sign over here. If only. There will be negative 3y minus y. And then I will get negative 4y, isn't it? Yeah, that will fit. However, if I put a negative 3y over here, then 3 times y doesn't give me negative 3y. How should I make these two, when multiplied together, give me a negative 3y? So clearly one of them has to be a negative. Because positive times negative will give me negative. I need to choose one of them to give me a negative. Okay, so I'm going to choose to put a negative sign over here. Now, negative 3 times y gives me negative 3y. Okay, I'm happy now. I've got my negative 4y. I've settled my negative 3y already. But we're not done yet, because the same problem exists for this negative y. So in order to make y times something to give me negative y, I need to either give a negative sign to the y, or I need to give a negative sign to the 1. You have to make a choice. And we will choose to put a negative sign with the 1. Why? Because negative 3, we multiply by negative 1, gives you positive 3. And now everything fits in place, everything falls in place. Everything fits. Now what if we didn't give the negative sign to the 1 over here? What if I gave the negative sign to the y? Then, sorry, not this y. What if I gave the negative sign to this y? So negative y times 1 is negative y, right? Oh yeah, it still fits, huh? Negative y plus negative 3y gives me negative 4y. However, when you take negative y, you multiply by y, you're not going to get y squared. And that is our problem. Okay, likewise, your negative 3 times your positive 1 is not going to give you a positive 3. So this all points to us having to put a negative sign with the 1. Okay, and now we have solved the puzzle over here. Our numerator is now y minus 3, y minus 1. Okay, next, over, and we have another practice again, y square and negative 2. So to get a y square, I'll have y and y. Now to give me a negative 2, I need a 2 and a 1. One of this has got to be negative. Either 2 has to be negative or the 1 has got to be negative. So the 2 weeks ago, before the holidays, I told you that, okay, we're going to be trying. Put a negative sign at the 2 and we see what happens. Then put a negative sign at the 1, see what happens. And then there were times in class when, wow, we spent so much time trying to figure it out. Then I thought about it. I think I have a tip for you this time. Okay? We can save us some time instead of trying everything else. So this is the tip. So listen carefully. In order to get the negative 2, I need 2 times 1. But one of them has to be negative. Never mind, don't care about the sign first. Don't care about the sign. Let's just put on what we have multiplied. So 2y as well as y over here. Okay? Obviously this does not solve the puzzle. Obviously this does not fit. Then we look at the sign over here. Oh, this is positive y. How do I obtain a positive y from a 2y and a y? How? Who should get the negative sign? Should a 2y get a negative sign? No, I don't think so. Should a y over here get a negative sign? Yeah, I think it should. So if I put a negative sign over here, then should a 2 get a negative sign or should a 1 get a negative sign? Now it becomes clearer lah. Okay, this bottom left hand box represents the area. The area is negative y. It is made out of the length of y multiplied by the height of 1. Currently it's 1. So in order to make it negative y, I need to put a negative sign at 1. No point putting the negative sign at y, because then you will get a negative y squared, which is not what we want. If we put a negative sign at 1, then it fits already. Negative 1 times 2 is negative 2. And here I have fixed the puzzle. So in the denominator, it will be y plus 2 as well as y minus 1. And I'm super happy to see this. Right, we can cancel already, isn't it? We already can cancel these two factors. And now, we've got the next fraction on the right. Okay, let's have our y square negative 15. So y and y. Okay, now, to obtain a negative 15, keeping in mind I need to get a negative 2y. In my mind, I've got 1 and 15. Any point trying that? 1 and 15. Is there gonna, if you put 1 and 15, you're gonna have 15y and 1y. Is that ever gonna give you negative 2y? I don't think so. So what other factors are there? 5 and 3, isn't it? 5 and 3. 5y and 3y. Is there a possibility of getting 2y? Definitely. Let us put a 5 and a 3 without caring about the sign first. Don't care about the sign. So 5 times y, we get 5y. Y times 3, we get 3y. Then I look back at the fraction. I need a negative 2y. Who should I give the negative sign to? 5y or 3y? Give to 3. I get to 3, then I will get a positive 2y. Then. Right. I don't want a positive 2y, I want negative 2y. So who should I give the negative sign to? I think I should give it to the 5. And now, negative 5y plus 3y gives me negative 2y. But I can't just do it this way. Either the 5 or this y has to have a negative sign. And clearly it has to be the 5. That's the negative sign. So that your negative 5 times 3 gives you your negative 15. Okay? So if you go through this sequence of steps, you will be able to factorize them accurately and correctly. However, if you have time, during your tests and exams, you finish already, right? You have time, check your work. How do we check our work? You check by checking all the areas, y and y. You get y squared. Yes, very good. Negative 5 and y. You get negative 5y. Good. Y and 3. You get 3y. Good. And the final one, negative 5 and 3, you get negative 15. And so, we check the final one, negative 5y and 3y, you get negative 2y. So this proves that we have already factorized it correctly. So y minus 5, y plus 3. Y minus 5 multiplied by y plus 3, no space. Y plus 3. Okay, now in the denominator, y squared minus 9. Recognize that the 9 over there is a perfect square. 9 is written as 3 squared. So we have another case of a squared minus b squared. Y plus 3, y minus 3. And again, I'm happy to see all this because more cancelling to be done. Y plus 3, y plus 3. Any more? Oh, y minus 3, y minus 3. And now it is simplified, way simpler, to give us y minus 5 over y plus 2. Okay? These are typical test and exam questions. Very typical. Looks complicated. But when it looks complicated, you should be happy. I know, most likely I can factorize them already. And it will become very simple at the end. Okay, so that is our 4.2. Let's move on to 4.3. And I realized that the video has actually completed most of the questions. Okay, this is the notes on addition and subtraction of algebraic fractions. The concepts used over here are the same as the ones you learned in primary school. Where we add and subtract fractions, we make sure that the denominators are the same first. Denominators must be the same. Then I can continue. Okay? And in order to do that, we don't just blindly multiply both denominators together. Cannot, huh? If you just blindly multiply the denominators together, you will get a very big denominator. And then chances are, you can eventually factorize and simplify. We don't want to do all those steps. That's why we find the LCM first. Okay, so in this case, part C, that was not covered. They have the same denominator already. So simple. All we need to do is to just combine 2 times x plus 1. Numerator is just 1 plus 3. You could have skipped this step to give us straight away 4 over 2 times of x plus 1. Okay? Now, I know that 2 weeks ago I told you the simplest form. I don't want to see any brackets. Remember I said that? Simplest form, I don't want to see any brackets. So you can either, okay, so you can write this as 4 over 2x plus 2. This is simple to work with, right? Simple. Then you take a closer look at this. On the left hand side, before I expanded the denominator. Using your understanding of the English word simple. Is this simple to work with? Is it very complex to work with, the one highlighted? Not complex, right? It's just a factorized form. Therefore, this actually can be accepted also. Now this sounds a bit contradictory, because in maths, we always expect one answer only. We always expect one correct answer only. However, the word simplify in mathematics, the word simplify in mathematics, there isn't a one fixed definition. As long as it looks simple enough, it can be accepted. But then what is considered simple enough? The very one of the basic requirements is that there should be no common factors. If there are common factors, they should be cancelled off already. Like what we have done in the previous two questions. You see, very complex, right? Fraction divided by fraction, fraction times fraction. It's not simplified. We try and cancel away all the common factors. Then the final form may look like this, which is a factorized form, where, wait, oh wait, no, there's still common factor. Hey, why nobody told me about this? So 2 and 1. Okay, so clearly this cannot be the answer. Now our simplified form is 2 over x plus 1. Okay, now this is just the final answer, 2 over x plus 1. If it can be factorized, you can go ahead and do so, but make sure all common factors are cancelled off. Okay? So let's move on to part D. Two over x plus 1. Okay, now in part D, remember, fraction plus or minus another fraction, denominator must be the same. How to make denominator the same? You can consider the LCM. You can. In primary school, right, if you cannot find the LCM, what do? Desperate already. Take the two denominators, multiply together, right? Multiply every day, see whether the final answer can simplify further. Wow, divide by 2 on top, divide by 2 below, divide by 3, 3, so on and so forth. But in algebra, you haven't exactly learned how to factorize all the different cases yet. At Sec 2 level, you haven't learned how to factorize everything, you haven't learned how to cancel everything yet. So the best case is always to find the LCM. Or if there is a way, make the denominator the same. Any other way. Okay? So now 1 minus x and 1 minus x, the denominators are the same. So you should be happy. We simply have 1 minus x in the denominator and 1 minus 3 in the numerator, leaving us with negative 2 over 1 minus x. Okay? Are there any other accepted answers? You know this negative sign, right? Originally belonged to the numerator, yes? Saw it as a negative 2, right? Then I brought the negative sign down to give it to the entire fraction. Yeah, we can do that. Or how about we consider putting the negative sign to the denominator instead? Would it still be correct? It will be, right? Okay, I'll just do it over here. So this is the same as 2 over negative 1 minus x. You probably can see now. We have 2 over x minus 1. Is this simpler? Right? Instead of having one extra negative sign outside, I don't have that negative sign anymore. Instead, I gave it to the denominator and 1 minus x became x minus 1. This is okay also. You can leave your answer like this, you can leave your answer like this. Both are considered simple. Okay? But if your OCD can remove negative sign, you want to remove negative sign like me, right? I will do this lah. Okay? Let's see what else is not covered. Okay. We are moving on to page 5 now. Part F. Page 5, part F. Fraction plus fraction. Primary school knowledge. Denominator must be the same. What is the LCM of V and U? No common factor. No choice, multiply them together. The LCM is simply VU. That is the LCM. That is our new denominator. It's going to be V times U. So in order to make the denominator over here, VU, I will need to multiply this by U. Okay, denominator multiplied by U. Numerator also must multiply by U. So I told you last year in Sec 1, don't write it this way. This is what you would have done in primary school. Because in primary school, we are dealing with just numbers, 3 over 5. Then if you want to times 4, you simply times 4. Nobody is going to ask you to draw brackets because you're only dealing with numbers. Drawing brackets not wrong. But there wasn't a need to in primary school. Because it was just one number in the numerator. Whether you draw brackets or not, didn't matter. But if you continue with this habit in secondary school, writing it like this, you may think that this is 1 minus u squared, which is not correct. Okay? This u belongs to the entire numerator. That is why I want you to draw it this way, with brackets. Always with brackets. Then you know, okay, the u must multiply to the 1. The u must be multiplied to the negative u as well. Okay? So we'll avoid some careless mistakes over there. Now in the second fraction, denominator is just u. I need to multiply it by v. So let's start on our new habit. Must draw the bracket. Then you multiply it by v. Next, equal to, in the denominator, we have u times v, v times u. Same thing. Are you comfortable with combining them already? Or do you still need to write them separately? If you need to write them separately, go ahead. Otherwise, try, skip this step, combine them already. You know the denominator is going to be the same. And now in the numerator, I have two parts. The first part belongs to the original fraction on the left. The second part belongs to the original fraction on the right. Instead of expanding and writing down the answer, I always recommend that you don't expand yet. Don't expand yet in case you make careless mistakes with the sign. Where is the careless mistake? It is this particular sign. If it is a plus, generally no problem. But if it is a negative, then we solved a lot of problems last year already. If it is a negative, we will tend to forget to take the negative sign to be multiplied to the negative v also. But today is positive, so it's fine. But let's just be consistent. v, 1 minus v. And now we expand. U minus u square plus v minus v square over uv. This is the simplified form. Okay? Next, part G. Part G, take a good look at the question. Look at the denominator. Any common factors? Any common factors that can allow us to find an LCM without simply multiplying the two denominators together? Have? Common factor? You have to see this d minus 3 as in a bracket d minus 3. Okay, this is not d times negative 3, it is d minus 3. So it belongs in one set. So in this case, there are no common factors. The LCM will therefore be d minus 3 times 5d. Okay? So this is what we are expecting. D minus 3 times 5d as our denominator. In order to get this denominator, the first fraction denominator must multiply by 5d. So in our numerator, multiply by 5d. Whether you draw a bracket around the 2 or not doesn't matter, because it is just one term. Now in the second fraction, our current denominator is 5d. I need to make the denominator the same. So I need to multiply by d minus 3. And notice that I put brackets for the d minus 3. So likewise, in the numerator, multiply by d minus 3. Because I'm not just multiplying by d and then the result minus 3. I'm multiplying by the entire d minus 3. So in the first fraction, what do we have? 2 times 5d. My recommendation to you was write down as 2 bracket 5d. But can be flexible a bit. 2 times 5d, we all can do it mentally, right? Instantly. I think we can write this as 10d already. Now, the part where we have a lot of common mistake is found over here. It is minus 8 times d minus 3. Minus sign. Earlier on I said this minus sign, very dangerous. So now all put your pen down, don't copy anything yet. I'm going to show you the wrong thing. Okay, don't copy anything. I'm going to show you what is going to be wrong. The wrong expansion. That means you're not listening to my advice. You try and expand it straight away. Instead of writing minus 8 times d minus 3, you already start expanding. Okay, minus 8 times d, minus 8d. And then you continue. 8 times negative 3, minus 24. Okay, this is wrong. Can you spot the error? Okay, who can spot the error? Raise your hand. Can spot the error? Raise your hand. Okay, put your hands. The error is found here, right? It should have been a plus. Okay, so how do we avoid this situation? Because this is very common mistake. How do we avoid this situation? I feel like I'm saying the same things over and over again. So we put on minus 8 times d minus 3. And then from here, we simplify 10d minus 8d. Minus 8 minus 3 plus 24 over d minus 3, 5d. Numerator will be 2d plus 24. Then put a 5d in front, d minus 3. And that's it. There are no more common factors that we can remove. Okay, so now try part H by yourself. Part H. Okay, so denominator, we gonna have x plus 7 multiplied by x minus 8 as our denominator. So that's the first part. Because we don't have any common factors. So in our denominator, x plus 7, x minus 8. Straight away can combine already. Okay, so let us multiply this with x minus 8, x minus 8. So over here, multiply this by x plus 7, x plus 7. So the first fraction, numerator will be 3 times of x minus 8. And then copy down the negative sign over here. And we have 2 times of x plus 7. 2x plus 7. Okay, so now it's just a case of expanding and simplifying. 3x minus 24 minus 2x minus 14. X plus 7, x minus 8. 3x minus 2x, that's just x. Negative 24 minus 14 minus 38 over x plus 7, x minus 8. Do you all get this? Do you all get this? Yes or no? Yes? If I made a mistake, you must let me know. The lack of response is a little worrying. So let me check my answer. 3 times of x minus 8. 3x minus 24 minus 2 times of x plus 7 minus 2x minus 14. X minus 38. X plus 7, x minus 8. Looks right to me. Okay, next. So this is a case of fractions with similar denominators. So I know that the teacher has already gone through this, but I just want to refresh your memory. The denominators in these two fractions, we've got an x minus 2 and the other one x minus 2 squared. So I've been saying over and over again, make sure the denominators are the same. Look out for common factors. If there are common factors, make sure your new denominator is the LCM. Instead of just blindly multiplying the two denominators together, they end up with something way bigger than required. So x minus 2 and x minus 2 square. The denominator is going to be x minus 2 square. We are not going to multiply both of them together. All I need for the denominator to be the same is just by multiplying the first denominator with another x minus 2. And then we have the same denominator already. So in the same way, the numerator just multiply by x minus 2. And that is how we get the denominator of x minus 2. So imagine if we didn't do this. You didn't realize that the denominators are the same. Let me show you what is going to happen. You don't have to copy this down. You're going to take this, you multiply it with x minus 2 power 2. So in the numerator times x minus 2 squared. In the denominator over here, you're going to multiply this by another x minus 2. Then you're going to multiply by another x minus 2. Let's see what we end up with. New denominator, x minus 2 power 3. Power 3 In the numerator, 5 times of x minus 2 squared minus 2 times of x minus 2. And then you're going to continue to expand. 5 times of x squared minus 4x plus 4 minus 2x plus 4 divided by x minus 2 power 3. You're going to keep doing. And then you realize that it's very weird. The powers are too big, the numbers are too many. That's when you should take a step back and look at the denominator again. Did I miss something out? There's a common factor of x minus 2. I could have simply multiplied the first denominator by just x minus 2. And skip all this headache. Okay, so the next one that was also covered in the video. Now look at the denominator again. X minus 2 as well as 2 minus x. In this case, you don't see common factor. So you might be tempted to just multiply the denominators together to end up with x minus 2, 2 minus x. X minus 2, 2 minus x. And then, as you continue doing, it will not be simplified. Why? Because the denominator can actually be made to be the same. X minus 2 and 2 minus x, they are very similar. All we need to do to change one to the other is by multiplying this with negative 1. In the same way, numerator times negative 1. What is going to happen over here? Look at the second denominator, x minus 2. So this is a plus. The second denominator becomes negative 2 plus x. Negative 2 plus x. Look, the denominators are now the same with a negative 2 in the numerator. Okay, so this is the other type of question, very common, that requires you to multiply both numerator and denominator by negative 1 to make the denominators the same. If you had gone to multiply both denominators, you will end up with something bigger. You will end up with a power 2. You end up with x squared, where the simplest form is actually x minus 2, power 1 only. So likewise for part C, and now we need to practice part D. Okay, please try this now, part D. Likewise, you have 2 minutes. Okay, what do you choose as the denominator? N minus 3a or 3a minus n? N minus 3a, I suppose most of you actually used n minus 3a as the denominator. Because in order to make that happen, I will need to multiply the second denominator by negative 1. Then it becomes n minus 3a, which is the same. But I cannot just multiply this by negative 1. I still need to multiply the numerator by negative 1. And if your mathematics reach the next level already, right, you wouldn't be thinking of this. This is the next level of thinking. I'll just show it to you. I'll just say it out. I'll write it down. If you cannot follow right, it's okay. Stick with this, you'll be fine. The next level looks like this. I change the sign inside. 3a minus n becomes n minus 3a. And then instead of putting a negative to the 7, I change this to be a plus. Okay? You can do that. But you must know what you're doing. How did all this happen? It happened because I wanted to make the denominator 3a minus n, change all the sign. 3a become negative 3a. Negative n become positive n. To do that, I multiply by negative 1. And then I multiply top by negative 1. So the denominator becomes n minus 3a. Then negative 7, right, in the numerator, I bring the negative sign down over here. It stays as positive 7, but this negative sign, I give it to the fraction. So that is what is happening in that shortcut. So here we have 2 over n minus 3a plus 7 over n minus 3a. And then, very simply, 9 over n minus 3a. Okay, that's quite a useful skill. You can change the signs this way. Next one. Okay, here. The same approach. Look at the denominators. Are there common factors? If there are, you can find an LCM. You can always find an LCM, but if there are common factors, there is an LCM that can be found, which is not just multiply the two denominators together. Okay, so look at this. X squared minus 4x minus 2. Wow, it looks like no common factors. It looks like I have no choice. Looks like only. I have no choice but to do this. Multiply by x minus 2. Multiply by x minus 2. X squared minus 4. X squared minus 4. So the moment you realize that you have a power 3, you better take a step back and look carefully again. Generally, we won't give you power 3. Not that it is impossible, but it's quite tedious. Generally, we won't give you power 3. The moment you find power 3, you look back again at the denominator. Can I factorize? Answer is, turns out you can. Where can I factorize? X squared minus 4. Don't forget the basics. X squared minus 2 squared. This is your case of a squared minus b squared. So this denominator becomes x plus 2, x minus 2. This denominator. And you see that, hey, there is the same factor, x minus 2, x minus 2. So the denominator that we should choose is actually x squared minus 4 as our denominator. Okay? So now, let's take a look at part B. Looks like a similar question. Okay, let's start. 2 over 2 minus x. This one, the first fraction you cannot simplify, you cannot factorize, you cannot do anything. But when it comes to the second fraction, 5 over x squared minus 4. You should be very proficient at this already. What do you notice about the denominator? Can it be factorized? Can. X squared minus 4 becomes x what? X minus 2 x plus 2. Okay, good, you factorized it already. But is there a common factor? Have or don't have? You know, we were hoping that after you factorize, right, there'll be a common factor. But the fraction on the left has denominator of 2 minus x. The factors on the right is x minus 2 and x plus 2. There isn't anything in common, isn't it? Or is there? Is there something common? Which one is common? It has to be related to this 2 minus x. Which one of this is related to 2 minus x? Is it the x minus 2? Or is it the x plus 2? Which one can you change to look like 2 minus x? X minus 2? Or is it x plus 2? X minus 2? All different, the x positive, this one negative, this one negative, this one positive. All different. But then this one, we have a positive 2. Wow, same positive 2. Whereas the x is of a different sign. So make a choice. Some of your friends have already made their choices. Which one should we manipulate to get 2 minus x? Just a quick survey, Who thinks we should be changing x minus 2 to become 2 minus x? Raise our hand. Okay, if you raise our hand, you probably know how to do it. Okay. Who thinks that we can change x plus 2 to become 2 minus x? X plus 2 to become 2 minus x. Nobody now. Okay lah, then that's a good sign also. Because there is no way we can change our x plus 2 to become 2 minus x unless we subtract 2x over here. But how does that happen? How do I just subtract 2x over here? I can't one. I can't subtract 2x here, then I expect to subtract 2x and make it the same, right? It's totally different. There's no such thing. So actually, we cannot change our second fraction, our second factor in the denominator to become 2 minus x. Our only chance is to make this x minus 2 to become 2 minus x. And how do we do that? We multiply it by, same thing like the same trick. Multiply this by -1. When you multiply this by -1, we get 2 minus x. Okay? 2 minus x in the denominator. Now, when I multiply by -1 in the denominator, I also need to do the same for the numerator. But I told you a trick. It's actually the same as changing this sign to become positive. Okay, but we can't do that over here. We can't just write it like this. Let's do it neatly. Okay, so just put a negative, oops. Let's just put a -1 over here. Then 2 over 2 minus x minus our, sorry, this becomes a plus already, 5 over 2 minus x and x plus 2. Now, our first fraction has to have another factor of x plus 2. X plus 2. So x plus 2. Denominator becomes x plus 2, 2 minus x. Numerator, 2x plus 4 plus 5. So we end up with 2x plus 9 over 2 plus x, 2 minus x. And this is the answer. Any questions? Can I put the denominator as something else? Can I put the denominator as something else instead of this? Instead of writing 2 plus x, 2 minus x, can I write the denominator as something else? Which is quite simple also. Can? What is it? What is the alternative for writing this denominator? What is in the denominator? 4 minus. Oh, is it? No. Yeah, 4 minus x squared, right? Then it becomes 2 plus x, 2 minus x. Can you see that? This is the same as 2 squared minus x squared. So you have 2 plus x over here, 2 minus x over here. So this is the alternative lah. But this is fine also. Oh, 6 more questions. Okay, let's try this. Part C. Denominator. Always start with the denominator. Can it be the same? Definitely. Are there common factors? Are there? 3p minus q. What about this one? Is there a possibility of extracting a 3p minus q from here? You see a common factor, right? 12 and 4. So 4 is a common factor. Let's see what we can get from there. So this is 4 over 3p minus q minus 2 over extract out the 4. So we're left with 3p minus q. Oh yeah, happy. Happy to see the 3p minus q? Yeah, because right now, all we need to do to make the denominator the same is to multiply the first denominator with, what do you want to multiply the first denominator with? What do we multiply with? 4? Anybody disagrees with Samuel? Nobody? Come on, I want somebody to disagree. Something else. Yes, Harry?
I think it's 2.
You think it's 2? Okay, 2 and 4. Samuel, what do you think now? 4 or 2? Rian thinks it's 2 now. Normally, we would have just gone with 4, right? Normally, don't you think just put 4 lah. But why is Harry saying 2? How about the rest? Do you think it's 2? Anybody thinks it's 2? Raise your hand. I won't ask you. Anybody else thinks it's 2? I won't ask you if you raise your hand. Only so few. Okay? Multiply by 4 is not wrong. It's not wrong. Okay? But there's a common factor here, right? This could have been 1. This could have been 2. So we multiply it by 2 over here. Then you multiply this by 2. Let's see what happens. So we have 8 minus 1 over 2 times of 3p minus q, which is 7 over 2 3p minus q. Okay, you can choose to expand the denominator if you want, but this is fine. Are you curious what happens if we don't divide by, if you don't multiply by 2, you multiply by 4 instead? What do you think is going to happen? You see, in this case, right, the LCM is actually 2 times of 3p minus q. So if you, for some reason, did not realize that, you multiply by 4, it is not wrong. But did you get the LCM? It's not the LCM, right? So in primary school, if that happens, what is going to happen to your final answer? It is not simplified. That means you still can cancel in your final answer, right? That's what happens. Do you think something similar is going to happen? Let's try. Let's try and see what happens if I do not multiply by 2. Instead, I multiply by 4. Okay? So, in blue, we have our 4 over 3p minus q minus 2 over 4 3p minus q. So in this case, if I multiply this by 4 and I multiply this by 4, what are we going to get? 16 minus 2 over 4 times of 3p minus q. 14 over 4 times of 3p minus q. Will you leave your answer like this? No, you wouldn't. You would have divided by, what will you divide by? Divide by 2. Then your denominator becomes a 2 and 7. Then you see that they are the same. 7 and 7 in the numerator, 2 and 2 in the denominator, then 3p minus q. It's the same thing. It's just that you are having to simplify at the last step, whereas we simplified at the first step. Okay, so mathematics is not broken. There are so many ways of arriving at the same answer, the same correct answer, as long as your fundamentals are strong and you know what you're doing. Okay, we don't cancel for fun. We know what we are doing, and that's how we have confidence to take shortcuts if needed. Next, please try this by yourself. Look closely at the denominator. Can they be the same? I tell you what, it is boring to give you questions where you have to multiply the denominator and the denominator blindly. It's very boring. We'd rather give you cases where you have to factorize and then make the denominators the same. Okay, so that is the clue for this particular question. The second denominator can be factorized to become n plus 3 n minus 3. N plus 3 n minus 3. So let's rewrite them. So 1 over n minus 3 minus 6 over n plus 3 n minus 3. Okay, so far? So we look for the common factors. Okay, there is a common factor of n minus 3. Over here and over here. So to make the denominators the same, I want the final denominator to become n plus 3 n minus 3. or you can write it as n squared minus 9. Both are simple enough. So the only change I need to do is to the first fraction. I multiply this by n plus 3. So multiply this by n plus 3. N plus 3 minus 6 over n plus 3 n minus 3. So we have n minus 3. N plus 3 n minus 3. What do you say your denominator was? He said n plus 3, is it? You said n minus 3, huh?
Yeah, I messed up.
Oh, mess up. Okay, but quite close, huh? Turns out, oh, we can factorize again. I mean, we can cancel again. Same thing, one. In this numerator, instead of just looking at it as n minus 3, we look at it as n minus 3 times 1. So yeah, it is a factor. Cancel it away. So 1 over n plus 3. So you see, something quite complex in the original question became simply 1 over n plus 3. So that's the idea of simplification. Four more questions. Yup. I think we can do this as homework. Or is there any one question that you want me to do with you in class now? Or are you okay with just spending the rest of the time doing this by yourself? And homework. Any one question you want me to do? Calling once, twice. H. Wow, you don't always think the last question is the hardest, eh?
Yeah, G.
No, she already said H. A G and H. No lah, one question only. G. Don't because I said the last question may not be the most difficult that you change on my G. Really G. Sure.
Wait, no. That one is
Which one? Yeah, who wants G? Raise our hand. Who wants H? Raise our hand. Yeah, H. So make the denominator the same. What is the denominator going to be? I see common factors already. 3 minus 2m, 3 minus 2m. So all I need to do is to make this denominator, you multiply this by m plus 1. So here also multiply by m plus 1. And then this 1 over here is the same as what we did in primary school. Change the 1 to become the same denominator and the same numerator. Okay? The denominator is just 3 minus 2m, m plus 1. So the numerator is going to be the same thing. 3 minus 2m, m plus 1. 3 minus 2m, m plus 1. Now in the second fraction, minus 5 times of m plus 1. Then minus 7. And then you go and expand. Expand using a rainbow for the first two linear terms multiplied to each other. Then go and simplify, you will get your answer. 3m plus 3 minus 2m squared minus 2m minus 5m minus 5 minus 7. 3 minus 2m, m plus 1. Arrange them, m squared first. 3 minus 2 is 1, so minus 4m. This is negative 2, so minus 9. Okay, I'll leave you with another question. Is this finished? Do you think this is the final answer? If this is not the final answer, what could it be? Okay, so this will be your homework, these 4 questions, as well as the next set of notes. So I did the most difficult question for you already, huh? But I'm leaving you to think, is this finished? Can I simplify further? That means can I factorize the top again? And then I find a common factor and I cancel again. Can or cannot? You need to go and try and factorize the numerator. And then you have a holiday homework, right? Zheng Jie, how long do you think you need to finish?
1